You often hear the term memory associated with computers. How much memory is in your computer? Is your computer running out of memory? When we're talking about memory, we are referring to random access memory, or RAM. This is the most common type of memory that you will find inside of our computers, but of course, it's not the only type of memory you might run into. When we refer to RAM, we're not referring to any long-term storage you might have in your computer. RAM is not referring to a hard drive or SSD, and you want to be very careful about differentiating between random access memory and the long-term storage that you might have in a hard drive. RAM is temporary high-speed storage that we use when we are executing applications and performing calculations in our computer. The only way your computer can work with data is if that data has been loaded into the RAM of your computer. So it's very common to load applications and data from your storage drive into active memory of your computer, process that data in some way, and very often we may need to store that result back onto your hard drive or your SSD. We've seen a number of changes to memory technology through the years, and every few years we tend to update and make enhancements to the memory that we're using inside of our computers. The speed of your memory is often associated with the overall performance of your computer. If you have faster memory, then you tend to have a faster computer. But a single stick of memory is not generally compatible with every computer you might find. Every motherboard is slightly different in what it expects from your system memory. So if you're ever performing a memory upgrade or you're moving memory from one system to another, be sure to check the documentation of your system to make sure that the memory you're installing is compatible with that motherboard. Instead of having individual memory chips that we would install or remove from a motherboard, we have a single memory module. We refer to this as a DIMM, or dual inline memory module. The reason we refer to this as dual inline memory module is that one side of this module has a series of electrical contacts. If we turn this module over, there are also another set of electrical contacts on the other side. And the contacts you see on this side of the memory module are different than the contacts you see on the other side of the memory module. Since there are two separate lines of contacts, we refer to this as a dual inline memory module. You might also see that information that is written or read from memory is done in 64-bit blocks. We refer to this as the data width of memory. So if you ever perform any calculations on how much information you're reading or writing from memory, you'll notice that those calculations use a 64-bit data width. Since we are putting all of these individual chips on a single memory module, it makes it very easy to install and remove from a motherboard. You can install and remove the entire DIMM at one time by simply pushing it into the slot. To remove this module, you would pull back the locks that are on the side of the module and simply pull the module directly out of the motherboard. If you're working on a laptop or another mobile device, then you're probably not using a full-size DIMM. In order to shrink things down into that smaller size required for a portable device, we use a smaller version of a DIMM referred to as a so-dimm. This is a small outline dual inline memory module, and it's about half the size of a normal DIMM. If you need to add or upgrade memory in a laptop, you're probably going to install a so-dimm. The process for installing memory into a laptop is very similar to the process you would use for a desktop computer, although you'll notice very often those memory modules in a laptop are installed horizontally to save room. You would slide the memory module in, push it down, and it will lock in place with the locks on the side of the memory module. Here you can see the difference in size between a DIMM, which is the longer module on the top, and a so-dimm. You can see that the smaller size of the so-dimm does make it a better choice for mobile and laptop devices. On the DIMM are installed individual memory chips. Those chips are dynamic random access memory. We refer to this as random access memory because you can access any data on any of these memory chips at any time instantaneously. We don't have to fast forward or rewind through the memory like you might have to do with a magnetic tape. We can instead reference exactly the data we need by simply referring to its address in this memory chip. The type of dynamic random access memory that we use in our computers is a version that is synchronous, or SDRAM. Synchronous dynamic random access memory is one that is synchronized to a common clock inside of your computer. That common clock keeps data moving inside your computer at a very standard rate. And since the CPU and memory inside of your computer is running at such a high rate of speed, having this common clock allows many of the components inside of your computer to keep track of a standard rate of data that may be transferred back and forth. There's another interesting technology that memory uses to be able to transfer data at higher rates of speed. An older style of memory used a single data rate to be able to transfer information from memory into CPU and then back again. And it used the clock rate to be able to manage this transfer of data. One single clock cycle would result in one bit of data being transferred. The next clock cycle would be the next bit of data, and the next clock cycle would have a third bit of data. In order to improve on that data transfer, we introduced a new type of memory technology known as double data rate. This DDR memory can transfer information at the top and the bottom of the clock cycle, effectively doubling how much information can be transferred from memory to CPU and back again. So going up on one clock cycle would be one data transfer. Going down on that clock cycle would be another data transfer. And you can see that we have effectively doubled the amount of information that we can transfer over exactly the same amount of time. The memory that you use inside of your computer is double data rate memory. You'll see it often represented as DDR, and there will be a number next to the DDR to designate the version of DDR that's installed. For example, your computer may have DDR3 memory inside of it. This is a memory module that was upgraded from the older DDR2, and although it could increase the total capacity that we could have on a single memory module, it was not backwards compatible with the older DDR2. So if you were upgrading to a motherboard that supported DDR3 memory, you would not be able to move over your older DDR2 memory. You might also find that your computer supports a faster type of memory known as DDR4. DDR4 also increased speeds over the older DDR3 technologies, and because this is a newer style and technology of memory, it is not backwards compatible with earlier versions of DDR. With DDR5, we improved on DDR4 by increasing the speed of the data transfers between the memory module and the CPU on the motherboard, and this is one that also is not backwards compatible with that older memory. And if we were to come out with a new version of memory with new types of technologies, it's very likely that the newer technologies would also not be backwards compatible. Fortunately, we built in engineering into these memory modules that would prevent it from being installed into the wrong motherboard. If you look closely at the memory modules themselves, there are small keys or holes at the bottom of the memory module that correlate to a key that's on the motherboard itself. This means that a DDR2 module can only fit into a motherboard specifically designed to fit that particular key space. If you were installing DDR4 memory on a DDR3 motherboard, you would see that those memory modules would not fit because the key is in the wrong location.